Okay, here we go. We're on page 4 in your packet. This is screencast number 1, section 4.1, Introduction to Atoms and Elements. Okay, first, there's a chart with protons, neutrons, and electrons. We're going to first go over this chart. So protons have a real simple mass. Their mass is 1 AMU. That's an atomic mass unit. 1. The charge of a proton is positive. We just draw it with a plus sign, positive. The location, where do you find these guys? They reside in the middle of the atom in the nucleus. So those are the basic factoids about the proton to start us off. Okay, you want to think like a proton. They are always positive. Okay, the neutron. Mass is also 1 AMU, same mass as the proton, it weighs 1. Charge of a neutron is neutral, and we draw that net charge as 0. Location, just like the proton, the neutron resides in the center of the atom in the nucleus. So that's the neutron. Moving on to the electron. The electron, these are a lot different than protons and neutrons. Okay, the mass is 0. Okay, they don't show up on the scale. Okay, they're essentially massless. They have no mass. Okay, very little mass. Charge, negative. Location, unlike the proton and neutron, the electrons are not found in the nucleus. They reside outside the nucleus in a place that we will call the electron cloud. Also known as energy levels. Some people call them orbitals. Okay, now we're going to draw a couple diagrams. So there's the first one. You can pause this for a moment and sketch this kind of small underneath where it says diagram of the atom. You can see that the nucleus in the center with the positive protons and neutral neutrons, and then the electrons found outside. So just give that a quick sketch. We're going to make another quick sketch. Okay, actually you can just look at that. Don't draw that. It's very similar to your first one. But you can see how that really is basically the same as that. That's our model with the protons and neutrons in the nucleus and electrons surrounding the nucleus. Okay, now we are going to draw this next one. This is what each element gets on the periodic table. Each element gets its very own little square. So I'd like you to sketch this. Okay, go ahead and sketch that. This element has not yet been discovered. Right now there's only elements up to 118. Someday there will be a 119 discovered, and a great name for it, great name would be Wendium. And you can see there's some numbers in that box. You don't have to memorize the numbers, but you do have to know what the numbers mean. So if you look in the upper left, that's the atomic number. We'll talk about that in a few minutes. Just go ahead and label that. That's the symbol. Every element has a 1 or 2 or sometimes 3-letter symbol to make it easier to work with. Bottom there, atomic mass. That's the average mass of all those elements of 119. Now the 2 and the 8, they refer to electrons. Okay, that's the electrons found in the first energy level. And 8 is the electrons found in the second energy level. Some elements can have 3, 4, 5, even 6 energy levels, depending on the element. Okay, now let's talk about the nucleus. Location, center of the atom. The nucleus contains 99.9% of the mass of the atom. The nucleus is extremely dense. Okay, it's almost undescribable how dense the nucleus is. Extremely dense. What 2 particles are found here? Once again, the protons and neutrons found in the nucleus. The atomic number, that's one of your vocab terms, and that refers to the unique number of protons. And every element, every atom of an element has the same number of protons. Okay, that's what gives an element its properties, the number of protons. Okay, so talk more about that in a few minutes. The next part where it says using your periodic table, we're going to do that in class. You can skip that section there. That's going to be something we'll do in class. Okay. Atomic numbers Again, it's found in the top of each element square. So you can see that if you look at the top there, boron's 5, carbon 6, aluminium 13. So that's the atomic number. You don't have to, most of those you don't have to memorize, but you do need to be able to find them if you are given a chart. Now, what happens if the atomic number of an element changes? In theory, what if you gave boron an extra proton and made it 6? The element changes. So protons are very important because that would change the element if you could somehow add a proton or take away a proton. So what determines the atomic number of an atom? The number of protons. The number of protons determines the number of elements. Number of atoms. Okay. We'll get to electrons next time. Good work with your first screencast, and I thank you for listening.